Hello world, how's it going? It's PD Codes, and welcome to the stream. Today we are going to be continuing with our work on my Mage Battle Royale game that I started last stream, so we are one stream in, not very far at all. And you can see over here on the left, I've got my to-do list. So in the first stream, we got through building the sample client that let our player move around the screen with keyboard controls. And then we got that client to build for both desktop and Mscripten. So it built for the browser, and we were able to run it in the browser. So let's show you real quick where we ended up. Let's do make, I think it's client run. This will compile everything for the client, and then just go ahead, or make run client, I think is what it was actually. Make run client. There we go. Okay, so you can see here, super exciting. We've got our little wizard in the middle of the screen. He starts in the middle of the screen, and then you can use the WASD keys to move him around. And similarly, let's try, I think it's make EMCC. Make EMCC. It's complaining about one of the files. Let's see. I wonder if I have. I think in the. Do I still have HBR? I don't have the HTML anymore. Oh, I gotta open up my chat here, because I legit forgot. Destroy computers, welcome. Yes, you are just in time, and I'm still trying to set things up because I didn't even think to open chat. So now we've got our chat open. Okay, hopefully I won't be ignoring you guys anymore. Good deal. Alright, let's open that bad boy. Got our dashboard. It's been a while since I last streamed. I apologize a little bit. Part of it was just been super busy with other things, and part of it has been that I was kind of floundering about deciding on my project and coming on stream and not having anything to actually work towards seemed not real helpful. So I think I figured out a little bit more about the Mage Battle Royale game that I'd like to build, and we'll get into that in a bit. The gist is it's going to be it's a battle royale game. It's going to involve some sort of wizard battle type thing. And as far as the technology goes, it's going to be written in C, using the SDL2 libraries to give me a pixel buffer for graphics, as well as for input handling and sound also. And the nice thing about SDL is one of the targets. There'll be two different clients.
we'll have a desktop client that people can install, but there's also, I'm going to try and use Emscripten to build a web client, so you can run the game within the browser. And the nice thing about SDL is Emscripten supports SDL. And if I can figure out how to get this thing to build again, I can show you that in a browser. So let's see. My client source is what? It's going to be client, so ls. I don't know what it's complaining about. No such file or directory. What are you whining about? I don't think I've touched this since last time, so it's kind of weird. Source client. So I've got main.c in my client. I wonder, reload file assets. Client target HTML. Joe Fish, how's it going? Welcome to the stream. Yeah, Destroy Computers. I am a relative newbie when it comes to building client-server code from scratch. So that will be a learning experience for everyone, myself included. A while back in my professional work, I did build a sockets library that worked with sockets on a Windows machine. However, that was a while ago, and I don't remember what language it was. It wasn't C. So this is going to be more closer to the hardware in terms of the networking layer. We're going to be calling using a lot of the networking system calls, and so we're really going to learn the ins and outs of sockets. So that'll be interesting, I hope. And this is an inauspicious start. Make EMCC. HBR is up to date. Let's do make clean. Just see what's going on. Source client main.c is there. So I'm not sure what it's complaining about in terms of what file is missing. Wonder if it's one of the SDL. Do I have a problem in my make file? Let's see. Nope, looks like everything's tabbed properly. Shout it out in chat if you're seeing what I'm missing here, because I'm sure it's something dumb. Make clean. So I can build the client target just fine. I can run the client on the desktop.
I wonder client target.html. So, I mean, user local include, of course, should be there. Got all that. We got our SDL too, right there. Excellent. Let's see.
I've been held up in this city for a while due to the rain.
Oh, I see. So as soon as
It can't find. Oh, you know what? Yeah, EMCC. Where the hell?
I hope that
It should
tonight,
be. Well, so
What?
if it continues, I'll be able to stay here forever.
it was in the path, but apparently it's not anymore.
That wasn't
Well,
meant to be a
crap.
joke.
Of course it's something obvious. Thank you, Destroy Computers. It can't find EMCC. Duh. So I think... let's see. Let me see if I can find it. Because it should be... It should be... Should be in my path. Let's see. It's in script importable. All right. I'm not gonna get derailed by this. I probably just have to set up my path. All right. So I have started working on putting together a basic networking library, and so right now I've got this networking header file. It includes this network packet, which let's open up that bad boy. So network packet right now, we basically just have an enum defining our packet type. Right now we just have a packet called packet test. And then our struct is going to have for the network packet itself is going to have a packet type. And then it's going to have the payload size in bytes and then a pointer to the payload itself.
Just as you don't know how you manage to be conscious, how you manage to grow and shape this body of yours, that doesn't mean to say that you're not doing it.
And then in our networking header,
we've got a client, a struct for the client, which has the address info, the networking address information, and then a pointer to the next client. So that's going to be like a linked list. And then we have something called a network context, which is going to contain the file descriptors for our reading socket and our write socket. And then I've defined a few higher level functions. So there's like network initialize. Then there's a function to listen for new connections. There'll be one to add a client to our client list. Hey, nice content. How's it going? And then one to read a packet, and another to shut down the networking. So this is the server side of things. We're going to, let's see, do I have, is it, there we go. So the C file that goes along with that so far looks like this. We're going to initialize our context, get the IP. I think when I coded this last time, I was thinking I was going to do datagram like UDP sockets, but I think I'm going to go for the TCP sockets with the streaming. We'll have non-blocking sockets, of course, but I do want them to be to establish a connection and hold that connection. So I think we're going to do AI passive means get the local server IP address. And so we're going to retrieve information about the local machine here, hold on to that, bind to the first socket that we can. I think, did we define a port up here? Yeah, so port, we're going to listen on port 1313 for now. And then if we bind to a socket, we will bind that to our reading socket. I guess that's really the listening socket. It's not really that's a misnomer. Should probably fix that. But this will initialize our context and our context read socket. Let's change that, I think. Is that buffer? Let's change that to get rid of this entirely because I don't think that makes sense. And we'll call this our listen socket. Listen socket. Zombie Brand, thanks for the follow. I appreciate it. Welcome to the stream. I apologize, it's taken me a little bit. It's been a while since I streamed last, and I probably should have reviewed my code beforehand, but you know, hey, let's just fly by the seat of our pants, because that's fun. Let's get rid of this guy, because Also, still learning VM, so, you know, take that for what it's worth. We'll do... We'll get to that later. We'll close this one. How would an MMO Battle Royale work? Well, I think by definition, a Battle Royale is an MMO. You have to... The genre is that you have a ton of people in the same arena, and they kind of battle to last man standing, like Fortnite or H1Z1 or PUBG or any of those popular games. I mean, technically, what we're going to have is we're going to have some server code running on a server that's going to listen for connections and then establish those connections and basically pass information to and from the clients. So each of the players will have the client installed on their machine, or they'll access it through the browser, and the client will, when it launches, establish a connection to the server and then pass information back and forth. In this case, the game itself, game logic will live on both the client and the server. The server is going to be the source of truth, because if you trust your clients too much, they can get hacked and the game can break. So what you want to do is have your server be the source of truth and not really trust the clients or not trust the information blindly. So as clients are passing information about what the player is doing and what it thinks is happening in the game, the server is going to verify that information, and then it will send out updates as to what the truth is. Excuse me. But as far as the game I'm building is, what high-level concept is, you're going to be a wizarding student attending a wizard school, and you're going to compete in kind of like a Color Wars type game, kind of like Splatoon, where you're going to need to use your magic to basically color as much of an area, as much as the arena as possible, more than the other teams that are competing, while taking out your fellow opponents or hindering their efforts. But I'm still trying to that's the high level. I'm still trying to drill down on those different ideas in my own mind, and as I figure things out in more detail, I will share. Sure. Let's just close these down for now. This is our server main, which we will hopefully get to in a minute. And these networking calls, this API will probably change as I drill down and figure things out. All right, so this is going to be our listen socket. That's what we called it. Yeah, I've never actually played Splatoon, but I've seen it played, and like I kind of had a similar idea, or came up with this somewhat separately, and then I'm like, oh wow, this is kind of similar to what I want to do. So it won't be just like Splatoon, but it will be. I guess it'll have a similar flavor. It's not going to be 3D graphics. It's going to be like top-down 2D. I thought about for a little while, since I don't want to spend a ton of time doing graphics. That's not the part that is interesting to me right now. I thought about doing it as like an ASCII mode game, but I think that would be really tough to try to figure out as a player, figure out what's going on, especially as more and more players join. I think the screen would just look like noise. But who knows? Nothing is set in stone yet. All right, so we've got our net initialize that is basically going to get information about our server machine, bind to the port on that machine, and then return the context. So then the next step, which you can see I have not done any work on. So the next step is to, once you've bound to the port on the server machine, you need to listen for incoming connections. So what we're going to do there and by the way, in learning about networking and the sockets programming, I think I mentioned this last stream, I'm using an online reference guide. It's called, it was written by a guy named Beej, I think. It's Beej, and it's Beej's Guide to Networking. If you are at all interested in low-level network programming at C, check it out, because sometimes the man pages for these different system calls are either incomplete or just not written in a fashion that makes a whole lot of sense. And Beej's guide is kind of written more conversationally, and there's jokes in there, and it kind of adds a bit of spice to an otherwise dry topic. So I would definitely recommend checking that out. So the next, what we need to do, we're going to listen for connections. So we've got, we're passing in our context. And so we're going to invoke the next call is listen. So it's going to be, it's just listen. It'll be our context. Oops. We're going to pass it the file descriptor for our socket, and then the next parameter is, here, let's see if we can pull it up. So it takes two parameters. It takes the socket file descriptor, and it takes something called the backlog, which it defines the maximum length for the queue of pending connections. So this is kind of like, how many connections do you expect to be dealing with at any one time, connection requests. And the reality is, for a game like this, you can guess. If you were building something like Fortnite, you'd probably have to set this really high because you're getting connection requests all the time. But for this game, I can't imagine more than a handful of people playing it at any one time, at least to start out with. So I think I'm going to set it to something like 10, which I probably wanted to find a constant for that. Did I do that? Call it backlog. So just do another define up here. We'll set it to 10. All right, and now the return value is an int, and it returns 0 if successful, otherwise it's -1, and the global variable error no is set to indicate the error. So what we're gonna do, oops, I'm still in insert mode. So we're gonna do if we get an error, then I'm gonna do something. I don't remember how we were previously handling. So I guess netlisten returns an int, so we should probably return a -1 from that as well. We can print a standard error maybe. Does that make sense? Let's do this. Copy this and put it here. Did that? I don't know why that indented weird like that. Okay, so we're gonna do failed to listen. And in this case, instead of null, turn, I think, just the -1. So listen for connections, if listen, blah, blah, blah. So if we get to this point, we are listening for connections. So for, just for giggles, do something like that. And now we're just gonna, so for now, I just want to have a simple test for the networking code, because like I said, I'm kind of doing this for the first time. So what we're going to do is we're going to just have the server listen for connections. When a connection is made, it's going to, you're learning C in school and just found out about Rust yesterday. I can't help but be angry at my teachers for wasting my time. So you think that, I wouldn't say that learning C is a waste of time. I think that learning C is really valuable in terms, even if you don't use C in your, if you're going to become a programming, development professional or that sort of thing, even if you don't use it in your day-to-day job, I think it's useful to learn C, because it really gives you a sense of what's going on at the lower levels. And everything, kind of all the other languages that are higher level, quote unquote, higher level languages, they build on that, but it's still helpful to know what's going on under the hood. Denstark TV, what is up? How's it going? Welcome to the stream. So the other thing about Rust, because I've looked at Rust too, and I'm like, you know, you read the Rust website and everything, and it sounds really cool. It sounds like it fixes all of the stuff that is quote unquote wrong in C. And so I went through their tutorial and all that, and it does have some nice things. But I mean, it's not a silver bullet, of course, because there are no silver bullets, and everything is kind of every language kind of has its niche. Rust is really good. I think that Rust has a bright future. However, programming in Rust right now is still a bit of a struggle. The tools are getting better and better, and if you're it's a great time to get in on the ground floor of Rust, and kind of if your goal is to have a long career in computer programming, then learning and participating even in the kind of the genesis of Rust could be great. You could become a expert in Rust and grow that into a career of being on the core team, doing conferences, educating other people about Rust, being an expert in that field. So like from that standpoint, it's great. But I don't think C is a waste of time by any stretch of the imagination. As if you're going to have any sort of longevity in computer programming, you're going to learn multiple languages over your career. So there isn't really, and you'll learn different things from each one. So it's just another tool in the tool chest. So what I was saying, we're going to do a real simple server. We're going to listen for connections. When we get a connection, we are going to accept that connection and then pass a message. Maybe we'll send, I showed you the network packet. Maybe we'll send a couple packets back to the client and wait for the client to send us a packet back, and then we'll just disconnect, and that will be that for now. But what that will allow us to do is test to make sure that we have all of our calls in the right order, and that we can have a client talking to a server and sending packets back and forth, and having the packet that we're sending be the packet that the other side receives and can understand. Because just to get to that point, I think there's we're going to be making mistakes and learning. So right now I'm just going to do we're going to loop forever on our server, although this shouldn't be our listen call. So perhaps our listen call ends. Let's jump into our our server code is going to look like this. So I have my server loop here. So what we're going to want to do is do our if net listen. I always do that. Let's see, net listen. Yes, I do publish my vimrc and stuff anywhere. It's here, let me see if I can drop that link.
I kind of stay to myself mostly, and I think I was sort of like the quiet person in like in the corner, more or less.
It's
checking out
GitHub
everything.
at PD
I think I
codes,
was still like in the state of like
and
how
I think it's dot files. I think so. I think that's it. It's something like that. If not, go to GitHub. Obviously, it's github.com. It's, you know, internets. So it's at github.com/pdcodes/.files, I think, or just go to github/pdcodes and it's one of the repos that are there. Is that yeah, string? You talking about string token? Yeah, it keeps internal state and mutating input. There's weird things, and you know what? Rust is going to have its weird things too. You just haven't found them yet. Rust has the whole concept of memory borrowing, and it'll take you a little while to wrap your head around that if you haven't already. And I think that there are situations where that can get a bit weird, but you know, every language has its idiosyncrasies. So, like I said, there is no silver bullet. It's whatever works for you. All right. So net listen. I think this takes my context, right? I think maybe if net listen. And then, so if this returns -1, I'm going to bail. And I wonder if I should use, let me look, I want to look at something. Finds the error message corresponding to the current value. Writes it followed by a new line to the standard error file descriptor. Not really sure the best way to handle errors. In this case, the error is something that's going to cause that's. I mean, if you can't listen for client connections, there's no point in continuing. It's definitely a game over type error where you terminate process. We'll do this, and then we'll do server. And then this is going to be this. So this will return from main. Will return -1 error condition. Yes. Probably doesn't like that. Declared it. Yeah. Declared that in. I thought server port was declared in networking.h, but. Oh, I didn't. I guess I made it private to this. Oh, and I made it a string because it needs to be a string for the. I need to kill this one. I guess. We don't need to have the port. we'll return -1, which will exit the program with an error. And so now we're going to enter our server loop. I suppose I can remove this to do. I don't really want to put this in main, but I guess for now it can be in main. So we have the while 1, which will loop forever. Or I guess we can do while true. Right? No? Doesn't like it? What? Oh, because I don't have true. Well, let's fix that. Okay, while true. Now, what we're going to do is we are basically going to listen for, we're going to accept connections. So, we've got a new, let's see, so what accept does an interesting, it will, I think eventually we're going to want to do non-blocking sockets. Accept blocks by, oops, there's not cups accept, what? Come on. What is that, Apple? Seriously? Can accept gives me cups accept? Okay, let me see if I can find that. Well, we're going to get a new file descriptor out of accept because what happens is it returns, it will accept the connection from the client and then it will return a new socket descriptor while maintaining the old one. So you'll have your old socket descriptor that we're using for listening to incoming clients connections, and every time we accept one of those connections, we can't reuse the we don't want to reuse the socket that we're using for listening because we want to keep listening. I guess there are certain client server situations where if you wanted a one-to-one relationship between client and server, you could use that socket, but in this case, we want to, I don't know how you would do that, but in this case, that's definitely not what we want. We want a client to have its own socket that it can talk to the server over. And so if we have a bunch of clients connecting, each client is going to have a socket connection to the server, and then there'll be one more socket being used by the server to listen for more incoming connection requests. So in this case, we're going to have a new socket descriptor, so we could do socket FD, I guess. And this will be our call to accept. And accept takes a couple parameters. It takes a descriptor to the listening socket, because it needs to know which socket is listening, and which socket is doing the accepting. And then there's a sock address pointer. I think it's a double pointer to the incoming client's address information, and then a size for that information that's being sent from the client. So we've got our and then I think we need to set up a it's weird. It's going to be a struct sock and storage. That's the type. Call it client address. And then we're going to need a size, which I believe is a yeah, it's a sock. Then it's going to be address size. Client address size, maybe. And we're going to need to pull in some header for that. Although, I guess networking. We should probably put all this networking up in our networking header file, huh? Probably starting here and ending, maybe? Oh. Not that one. That would be weird to include itself. Okay, so let's... Seems good. So now we know about our sockadder storage and our size. So yeah, so let's go here. So this is going to take it's going to take our let's see. Where am I? it's going to take a pointer to the client address thing. And then, again, we're going to pass this by reference as well, the CA size, so that they can write into it. And what does accept return? Yeah, so then we can check the return value, because it'll return, again, -1 on failure. Otherwise, it's successful. So if this means we're going to fail to accept this, which I think if we fail to accept a client, I don't know that that's that's not something we want to shut down the server for. Because, I mean, if we've already accepted a bunch of client connections and we've got a running server and we fail to accept a new client, we don't want to shut down the server for that. So let's just print the error, accept, and then we'll continue looping. What's it complaining about? Be whining about. Doesn't like socket or storage. Is that the wrong thing to be passing? Got here. Oh, there's one thing I forgot. We need to initialize this value, and this is set to size of, it's going to be the client header, I think. Struct sock header storage. It's expecting a sock header. Go to the man page, man. Accept. This is the Linux one. It should. Oh, this it takes a sock header. Seems good. Okay, let's try. Guess that's not. Let's see. Interesting. All right, so if we fail to
except that's not worthy of terminating the entire server. So we're just going to continue. We'll log the error, and we'll just keep going. And so then the next step, we're going to want to print some debugging stuff. So we'll do printf accepted connection from, and we'll do an IP address here. We'll want to log this, and so we'll need to I need to turn that into a string first. So let's just do it, and then I can explain it. Inet do this client address family. I think I need to write that. So get the IAN address. This is where it's going to take the Oh, you know what? You know what I did? That's the problem. This absolutely should be a sock address storage. It's a weird, however, when I cast it here, I do want to cast it to a sock address. It's compatible with this cast. So then I want to do the same thing here. Struct we'll do the client and get IAN address takes that. I need something here. It's array, and it's going to be call this IP string. It's going to be of size need to allocate a buffer because then we pass that buffer in to here. Let's hit that. And then we do size of, I believe. So what we're doing here is we are allocating some space for to hold an IP address string,
And then we are getting that. I've got my thing in the wrong place here. We're getting the address. We're going to stuff it in that IP string field. So this is basically going to be IP string. However, I've this call here. So it's not this one. N2P. So what? Basically, there's presentation format address to format. So what we're doing is we're taking, here it is, converts the address from the network format, which is in network byte order, to presentation format, which is in host byte order. And so basically for networking purposes, network byte orders is a standard so that everybody talking over these sockets sends their bytes in the proper order, as opposed to like big endian or little endian. You know, the host machine can be one of those, either big or little. However, network byte order is big endian, I believe. So it sends all of the bytes from most significant byte to least significant byte, as opposed to little endian, which is the so what you need to do is when you're handling your networking calls and you're accepting data and sending data over the network, you have to make sure that when you're sending data out that it's in network byte order, and when you're accepting data in, that comes in via network byte order. However, if your local machine is different from that, you need to convert that data to the host machine's byte order so that it can understand it. But there are system calls for both of those, so we don't have to worry about rearranging the bytes. We just have to remember to call these functions. All right, and I've blown it somehow. So let's see, what's the signature for this? N2P. It takes the family, address family. It takes the source, which in this case is going to be our get address, and then it's we send it the destination and then the size of that destination. So the problem is with our source. Let's look at get IN address. Oh, I did man. Oh, that's not nice. Oh, I think is that a function we wrote? Maybe we didn't write it yet. We didn't write that function yet. We need to write that ourselves, I believe. Yerp. It should be in our networking library. So let's do that. Write this. We'll go to the next buffer. We'll go to networking. Just do it here. So it's going to return
get. Let's go to. Oh, do I have it here? There it is. I already wrote. I thought I wrote it. So I guess we just need to declare here. We've got it in our. Is it? There it is. Yo yo yo. Busta rhymes. Now I'm just being pedantic. I think I want all these on one line because, yeah. Alright, so now that call should resolve. Yes, it does, because it was part of our... We just needed to expose it. It was in our C file. We didn't share it publicly, but I guess the way I've got things structured right now, we do need to share it publicly so that main can see it. We'll print the fact that we accepted a connection, and we'll print the IP address of that accepted connection. And then what? Then we want, okay, so here's where it gets interesting. So now we have a file descriptor for our listening socket. We have a file descriptor for our new socket for the incoming connection. And so what we want to do now is this server loop is just going to keep listening for connections. So we need a way to now start interacting with the client that we just accepted a connection from. And the way that we do that is we fork a new process. So we're going to fork a process that will then handle running the game for this particular client. Meanwhile, the parent process will just keep looping through this server loop, listening and accepting incoming connections and forking new processes. So next step is we fork the process, which is, I'm not gonna go there. So here's what we do. We call the system call fork. Will I use pthreads? No, I'm not going to use pthreads right now. I'm just going to fork the. I suppose I could. The other way I could do that is I could create a new thread and handle the client, each client on a different thread. But let's just see what happens here with this fork. So I think one of the benefits with maybe forking the process is if a client errors, if that process somehow gets taken down, it won't take down the whole server. It should only take down that particular client. Whereas with threading, everything's in one big process. If one of the threads throws some error or exits abnormally, then the whole process just dies. So this, I think, is a bit safer, keeping things in their own sandboxes, so to speak. We'll see. I don't know.
again, this is a learning process. This may turn out to be a super bad idea, but that's what we're gonna go with for now. So what happens here is, oh my gosh, my typing is crap. Okay. We're invoking the system call fork. It will fork an exact duplicate process. So with one difference. I can't remember exactly where. It's a long time ago since I read this, but basically when you fork a new process, there is one distinguishing characteristic. It's the return value of the system call that indicates whether you are in the original process or whether you are in the newly spawned fork process. So if the fork system call returns, I guess it's false, I think, or some value of false, it means that you are in the child process. So yeah, exactly. Shared state management could be a problem, which we may end up doing threads. I haven't quite figured out exactly how I'm going to do state management yet, but right now I just want to get the networking. I want to get clients talking to servers and sending information back and forth, and then I will figure out how to do the shared game state on the server. But I mean, I feel like this road has been trod upon before, so I'm gonna do some googling on the interwebs and try and figure out exactly the best way to do it. Open files and file descriptors like sockets, will they get duplicated? Good question, and the answer is yes. So what we'll have to do, you'll see, we're gonna basically clean up the stuff that we don't need. T-Soding, thanks for the follow. Hey, I was watching you earlier. I enjoyed your stream earlier. Welcome to my stream. T-Soding is a fellow C programmer, so if you like watching folks program in straight up C, he also does games, so give him a follow. Welcome to the stream. So to go back to the question, the answer is yes. All that stuff is duplicated. So what we're gonna do right now is so this is the child process. So what we need to do is clean up. We don't want the listening socket, right? So we're going to close that. Because we don't need that. We don't need the listener. And then conversely, let's do so we can do else. This is the parent. So the parent doesn't need the new file descriptor that we just created, our new client one. So because it's just concerned with continuing to listen. So we're going to close client. What the hell did I call it? New socket FD. New socket. Okay. So we fork the process. In the child process, we're going to close the listening socket because we don't need it. And then in the parent process, we want to continue listening. We no longer need, we're not going to need to access this socket. So also what we're going to need to do, we're going to need some way to retain the new client socket that we just So I guess at this point, this is where we would put our do server stuff, right? To do, right? So what do we want to do just for this test? We can just send a message. So we'll test sending. Let's just do send. So there's another call, send. It sends information to the across the socket. So in this case, we're going to send it over our new socket FD, and then we're going to send it a message. So let's look at that. Send. It takes the socket. It takes a buffer. And then the length of the buffer and some flags. And flags can be not anything I think we need to worry about right now. So let's just do server. And then we need a length here. So we've got, what do we got? 1, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 1 for good luck and a null or a null character terminator. So 23. And then we're going to send that. So if that is, of course, equal to -1, which is our failure value, we need to print our fail. We will flag that. And then I think we're going to just, at this point, we're in the child process. Okay, let's just, we're gonna need to, let's just put a comment here because this is just test code, and then we'll have test code. And so what we're gonna do is we will accept our connection. We will print or send a message, hello from the server, and then we'll just exit, I guess. So we'll close our connection. So we'll close our new socket FD. Socket FD, and then we will exit our process. In this case, we'll exit with success, which is 0. And that should be a decent enough test. Once we figure out that everything is working with our connection and everything, then we can dive into the meat of
actually implementing useful server code. But, okay, so I think to double check my stuff here. Let's do, seems not even worried about packets yet. I probably should just close that so that, let's close this bad boy. I want to check and make sure that I'm setting up my sockets properly, because originally when I started, I thought I was just going to do UDP sockets, just kind of fire and forget, but I've kind of come around on that a little bit. So what I want to do, sock stream, and then AI passive is right. I think that's good. Get address info. It's not server port 1313. Gonna bind. Why is it highlighting all? I still have stuff that it doesn't like. Net shutdown. So I'm gonna need to. Let's just satisfy these. Turn. This will be to do. Ditto for this. Just going to return 0 from return. What else are you complaining about? Anything? Unused parameter. That's a warning. Not going to worry about that right now. We know it's unused. Alright, everything else. Looks okay. Hey, Yusha. What library am I using for the interface? Are you talking about the eventual user interface? I'm going to be building my own kind of rendering engine on top of SDL2. Is that what it is? No highlight? It's highlighting my last, that's my last search term? Brilliant. Love those Vim tips. Keep them coming, because I'm a noob. Alright, so this seems okay. Let's see what we got going. I forget. Do I have server instructions already? I do. Server target. And I called my server target what? HBR server. So make. Got warnings. However, we built successfully. Yep, and it's just the same warnings that were surfaced inside Vim. Okay, so it looks like our server built successfully. Whether it runs successfully is a different story.
Well, it says it's waiting for connections, so I guess that's a good thing. Okay. So now we need to write a client that will actually send those connection requests. I don't think we have any work on that started yet. So we probably want to write a little test program. So I don't really want to build this into my this is my client main right now, which, crap, why didn't I do that? Let's see if I can get this read. So this over here is my client side. Which basically just spins up, initializes SDL, creates a window, full screen window, and then puts my wizard on there and accepts the WASD keys to move them around. I think I almost just want to write a separate little program that will test the client. So let's do this. I think I test folder here, and I'm going to add a child node to that. I'm going to do network client.c. Open that bad boy up, not like that. Is it opening everything in the split windows? It was. Hold on. Time to look up Vim. It's edit at E. Source test. Oh wait, no, it's not. I should move that test folder under. I'll move that under source because it's all my source tests. Something to worry about later. So let's just write a super simple client string. This is gonna need the same stuff. What time are we at? 3:09. All right, I'm gonna have a hard stop probably around 3:45 or so. So hopefully we get our client talking to our server before then. Okay, so we're gonna need this stuff, and then we'll bring in our standard includes as well. That.
I'm gonna bring in my networking as well because let's see. So I'm just gonna connect it on, let's see. We're gonna take, in this case, we're gonna take, we are gonna take command line parameters. We'll take the name of the server, the address of the server that we connect to, perhaps the host name. You like the music on Thin Stark? Nice. Yeah, this is I suppose we should turn on some Barry White, huh? This is what is it? How do they classify this music? This is relax and chill beats. I would agree. It's kind of chill. Although baby making music, I guess that's another way to classify it. If we'll do shit. A little usage message if they screw it up, and we're gonna basically want this to be what are we calling this? Network client. Host name. We'll exit with an error. Otherwise, we will keep going. So, I should probably just borrow a lot of the initialization code here that we do, because we're going to need to... Maybe I should move this directory now, because a lot of this stuff is... I could reuse the networking. Reuse the networking library. Let's just return 0 for... Stop complaining. Yes, argv is unused for now. Get over it. Let me close this. Do some quick. File J. Source. Alright, let's move test under source. Source, test, this one. Okay, now what we can do is we can do include it's not shared yet. It should be though. I have to do some cleanup on my networking libraries to make it more. I will put them in the shared folder. However, they're not truly shareable quite yet. Let's just do this for now. Oops. Because I want to be able to reuse this stuff. So, what do I want to reuse? I want to reuse the net initialize, and that might be it. What that will do is that will initialize. It binds to a. It sets up the networking environment, it sets up the socket type, which should be the same on both sides, and then it binds to the first port that it can, and returns the context. So what I need is a network context T. And that should equal net. That should come back from net initialize. Hooray, hooray. Can't even remember anymore. It doesn't take any parameters. Okay. Good. So that will set up my socket. I can press cap A. Yeah, I always forget about that. Alright, so net initialize will create my socket, create my descriptor, although in this case the context it's calling it listen socket file descriptor, which is not, it doesn't make a whole lot of sense from the client side. So we'll have to do some work making the networking code more shareable, more generic. But for test purposes, it's fine for now. So we've initialized our network apparently at that point. So now from the client side, we want to connect. And let's see what we, actually, I don't want to bind to the port at all, do I? Yeah, screw this up. We don't want this at all. Because binding is just something that only happens on the server side. So what we want to do is we want to get the address information about the server given the host name, and then we want to connect to servers can return, or host names can return multiple structs containing address information, so we'll loop through those structs and then connect to the first one that we can. Because they may support IPv4, they may support v6,
We could bind to a specific one or connect to a specific one if we really cared, but I think for testing purposes, we'll try connecting until we are successful. So we need to, it's similar to the server side where we set up hints and we try and get, let's just do it. So we've got we're going to have an address info struct on this side, and this time it's going to be, we're going to need one of these. And then we're going to need going to need serve info. Why do I already have that as something that's resolving? It's pulling it in. Maybe I use it in networking and it's still, it hasn't cleared the new completely cache there. Not that. So what we want to do first is we want to clear the memory for hints, because hints is a structure. Who knows what kind of garbage is in there. We'll send it some hints, set it to 0, and then the size, give us a blank slate for hints, and then we're going to set some hints. So what we're going to set is the AI family again. Why is this behaving so weird? Okay. AI fam. Why does it say flags? Super weird. Our hints, our AI family is going to be set to AF unspecified, which means grab the defaults, and then we're going to set our sock type to sock type sock stream, so everyone's streaming sockets. Let's see, so we're gonna do, so this is where we get our address info, and we're gonna send it the host name that is passed in via the command line, and then we'll set, I'm just gonna do this because we know it's port 1313, it's gonna hard code it, add, an address to our, pass in a reference to our hints, and then it is going to write into this last bit, which is our server info structure. So if get address info is successful, it will, I believe, allocate the space for that and write into the serve info that we're passing in, and that will fail if it's a 0, which is a little bit unlike the rest of the calls that we've been seeing. And I missed it. Yeah. So if it's, testing for not equal to 0. So if it's not equal to success, we're gonna we'll print a standard error again. Get address info. Some kind of failure message here. Do that, and then we'll pass it the. There's actually another call that we can get. I think we pass it RV. That's our. And so at this point, if we don't get any address information, we're just going to return. I guess maybe return fail from our. What's it complaining about here? Mem said doesn't like my declare. What did I? It's in string.h. I didn't include that. That one always gets me. String.h. Man pages to the rescue. Okay. So we get our address information. If we do that successfully, we are going to, again, like I said, we're going to loop through the results, and we're going to, because there may be more than one, it may just be one, we're going to just loop through them and connect, try and connect and until we're successful. So we've got for, what's that? It's going to be struct. That's going to get our serve. Because serve info, yeah, it's a linked list of stuff. Yeah. And we're going to loop until p is not equal to null, or while p is not equal to null, and then we'll do p equals p AI next. That one. So, what time are we at? 3:30. We're a bit close. All right, let's see if we can do this. If we're going to create a socket on our client side, and it's going to be from the information. I did that again. We wanted the family that we're given, and then the sock type that we're given, and then what's the third to socket, the other call to socket protocol. So if that's a fail, again, oh, and I actually need to, I need to declare sockfd, int sockfd. Let's do that up here. Singaporean somewhere. All right, so if we're in this loop, we had an error, so we're gonna do, we'll fail. if we're successful and we get past this, then we're going to connect. So the next call is to connect. And let's look that up real super fast. Man, connect. Takes the socket descriptor, the address information, and then the length of that address information. So we're going to do connect. It's going to be the sock FD that we just got. FD. And then the address info that we got, that's our P, right? I think. And then, there's a, and then size of, I think, this, right? Maybe? How's everyone going? How's everyone doing out there? Oh, crap. I don't actually need to do a size of, I just need to, it's already fully stored right there. Address, I should not use the arrow keys on, it does not like, you complete me when you use the arrow keys is not happy. And connect is going to fail, of course, on a -1. We'll fail on connect. I guess we'll put client in there as well, just to give us, and we'll return failure. Code. Oh, so that's right. We don't want to return in this case. We want to continue because we're looping through. This case is a little different. So we're going to loop through. We're actually going to close the socket. We're going to log an error, and we're going to continue on to the next address info structure in our linked list. And then once we loop through the end, if we haven't connected, then we're going to fall out of the for loop. So we should probably check for that. If we get past connect, we're successful. So let's just break out of the loop. We don't want to keep looping and trying to connect because that would be bad. So once we fall out of this loop, we want to check and see if we've got, see, that's the problem. I needed this. I need to save this. Okay. I need struct this guy to be longer served. So we'll do this. So now we want to check if P is null, then we loop through all of our socket or all of our address information, and we were unsuccessful in connecting. So let's print failed connect server. And we'll exit -1. Okay. Otherwise, so now if we get here, we are connected. So what we want to do is we just want to, let's see, we sent on the server side, we sent that message, so I guess we should,
the client side, you want to do receive. Receive a message from a socket. It takes the socket file descriptor. It takes the buffer to read into length, and then a bunch of flags, which I think we're going to ignore the flags again. We ignored them on the server side. And it returns the number of bytes received or -1. So we need to create a buffer for this stuff. And I think we'll just do, let's just create a simple char buffer. We're gonna, oh no, hard code some stuff. Let's just do buffer size 100. And we're gonna receive into that. So byte count, maybe? Or we can just do, let's just do receive. It's going to be our sock FD. And then our buffer, I think we pass in the address to our buffer. And then the, I guess it's this, the buffer size. We need to leave at least, I wonder if I need to clean up set my buffer to be a bunch of null. So yeah, I need the null terminator. So we're gonna do longest string that they can send us, or longest number, maximum number of bytes is going to be 99 here, because we want to leave at least one character for the null terminator, and then we're not setting any flags. So let's do this. So I should do buffer. And this is all hard-coded crap, so, you know, it's test code. Set that to our null terminator. So there'll be what the server sends us, and then some garbage, and then the null terminator. All right. So what we want to do is check byte count. If byte count, then we failed. We didn't get any receive. We didn't receive anything. So we're going to do receive failure and exit because we're unhappy. Otherwise, if we get to here, then we've read stuff into our buffer. Maybe we print that? Okay, good, that error went away. Okay, so if we get here, then theoretically nothing has exploded. Let's do a victorious print. Client received I before E except after C. Do this. So it'll just store that in our buffer. We'll give it the, no, just give it the buffer. And then last but not least, we want to close our socket, right? So,
think that's... I think that's everything. Alright, let's see if we can get this bad boy to compile. So, we're in our test. Source. Test.
I'm going out with some friends later if you want to come.
Test
I'll see you later.
client. And we're gonna do test client as network client. Derp. Network client C. Oh, it built. So let's just run it right now, see what happens. Nothing. Oh, our host name, yeah. We should put these some old line feeds into these bad boys. Got one. Okay. Let's do one at the end here. Client received. We'll do that, and then we'll do this. Yes, new lines on all the printfs. That's what we need. Welcome to the stream, JK BBWR. I don't Bibberwer. I don't know how to pronounce that, but welcome to the stream. Okay. So let's build that. Do yes. Now we need our host name. So we're gonna need to run. Let's see. Can we just do connection refused? Failed to connect to server. Of course it did. So we're not running the server code. So let's do that. Window here. So here we will do. Do I have? Let's see. Do MHBR server. Boom. Waiting for connections. Let's see what's what, and the moment of truth, ladies and gentlemen. Okay, so they're both hung. Fail. Throw up a test server with netcat. Oh, well, I'm trying to test my own server, so I've got theoretically built a server that listens for connections. So I wonder what. I need to add some more debugging to the server to figure out exactly that, making sure it's doing the right thing. Client, making sure that it connects to the right. So that's super weird. Like, it just sat there. Where would it have gotten stuck? Is it just sitting in like a loop here? Is my for loop busted? I think so. It should loop through. Let's put some printfs in. Let's go down. Does it connect? If connect is otherwise it falls out. If it's null, it should report that it failed to connect. Otherwise, oh, maybe the problem is it's connecting, but it's not. So it's waiting on the receive. That's what's going on. It's blocking on the receive. So maybe on the server, I never got this server accepted connection message though. Do I recall? Net listen. So did I implement that? First things first. Let's see. Listen. I never got to the waiting. Did I get the waiting for connections? I did. Okay, so I got here. While one. Look at. I never deleted my freaking code. An idiot. I never. It was just sitting there on a wait loop in my forever loop because I was originally gonna put my listen loop there, and I didn't delete it. Yeah, that's definitely worth laugh. Idiocy, I tell you, idiocy. It's always stupid stuff. Okay, let's build this again. So we'll do make HBR server. Hopefully we don't have stupid things now. Still got just the warnings, so we'll do mage server. Waiting for connections, and now we're gonna connect. What? Client received hello from the server. Boom. And client server accepted connection from. That is the IPv6 address for localhost, so that is good on both sides. Awesome. See, you removed the stupid do nothing loop, and everything is copacetic. Hooray! And that's perfect timing for me. I gotta call a hard stop. But I'm glad that we were able to get some success there. Denstark, you trying to spam caps? Yep. Don't make Nightbot slap you down. No, that's super cool. So we've got like the bare bones. We've got our server able to listen to connections. Our client. We've got the client code that we can then integrate into our networking library, making the client side of the connection and receiving data. So we're gonna, that's the very first step. The next step is kind of expanding on that. We need to make those sockets non-blocking. So you saw how the receive on the client side, the receive was blocking. It was just sitting there. For our clients that are, that's unacceptable to have to wait on networking operations. So we're going to want those to be asynchronous. We'll need to set those sockets to not block, so that we can then kind of poll for information. Epoll select style. We'll probably end up doing that because especially if we're running in a browser. And on JavaScript, like you can't block that stuff. I don't think Emscripten and the net sockets, they don't support blocking. Your sockets have to be non-blocking. So we're going to need to do a little bit more work there to set up the sockets slightly differently. And and then I want to clean up the. I am compiling via mscripten. I am. I need to figure out. Somehow I broke it off stream. I need to set up the scriptum compiler again because it's not being found by my makefile, but it was. If you watch the vid from last stream, you can see I set up the mscripten compiler and had the client, my super simple client building for both desktop and client. Pain in the butt, yeah. We'll see. If it's too frustrating, I'll just go keep, I'll punt on it and develop the desktop client, but if it can dual build, that would be super sweet. So lots of work yet to do, but this was an encouraging start on the networking side. So I'm pretty happy with how things turned out. I'd like to thank everyone for joining me today. If you haven't already, be sure to hit the... Oh, look at my background. Oh, I gotta move my chair in. Can't have those. There we go. Oh, wait. Nope. Oh, there we go. Okay. Don't move. Thanks for watching. I'll be uploading the code to GitHub. Where am I at with the main core? I'm on day 2 of this project, so there's like nothing basically. We're gonna build it all. So stick around. Hit that follow button if you haven't already. You'll get notified the next time I go live, which will hopefully be on a somewhat more regular basis. And keep an eye on the GitHub because I will work on this a little bit off stream, but I will be making those commits to GitHub. And if you want to connect, hit me up on the Twitters at PDCodes. But thanks for joining me today, and I hope to see you again in the future. See ya.